Edging towards the end, let's look at the transients in the Great Cloud Band, which we called high frequency variance in OLR and so on before. So again, looking at OLR and the stretching information between 20 south and 35 south in the longitudinal band. So these are times, and you clearly see propagating features, but it's not always so clear. So one has to be careful about what theories can explain these things. But in general, you see some relation between the stretching information and OLR, which is consistent with the discussion we had before about modulation of the waves by the basic state stretching information. So du bar dx being less than 0, greater than 0, waves getting shorter, group velocity decreasing, energy being deposited. So we are in a different regime here than the inertial instability that we kept talking about in the ITCZ case. So looking at climate versus the 2000 climatology versus 2005-6 DJF in the same band, you can see that interannual variability is not that great compared to the climatology. This is the 2005 and 6, and the climatology is shown in the black or the solid line, and stretching information is also given here, so you can read the caption to make sure. Haumüller of the OLR shading depicts values less than 240, which is deep convection, 200 hectopascal zonal stretching deformation, which is what is always critical for waves, during the period 1st December 2005 to 2008, not 28, February 2006, zonal stretching deformation contour interval, etc. Averaging done over 15-degree latitude band that we already saw. The second diagram shows, the second figure shows 2005, 2006 DJF and 27 season climatology of the outgoing long wave radiation in blue and zonal stretching deformation in red. Gray shading depicts regions of negative climatological zonal stretching deformation. Okay, so there is negative zonal stretching deformation here where convective activity is strong, so there is a clear drop in OLR below 250. So we are obviously picking various thresholds, but it doesn't matter. The minimum in OLR are associated with the negative stretching, and that corresponds to the upper level stretching and drop in OLR as well. Okay, so again, consistency check with what we have done before. Looking at the southeastern Indian Ocean and the SPCZ at 30 south, same latitude, but in the Indian Ocean sector and in the Pacific sector, southeastern Indian Ocean and the southwestern Pacific Ocean, you clearly see again shown here are again OLR and 200 hectopascal zonal stretching deformation. Okay, so the base points are different, so these are regressions of at 3 to 6 day band pass. So obviously whenever you see propagating features, there is some band passing that has been done. If you just look at the totals, you don't necessarily get these features. So use these as the base points and then do regressions to extract the features. So again, the same story. Negative stretching corresponds to low OLR, and the consistency of the theories works all the way into this. So these great cloud bands in the southern hemisphere are very critical for something we had seen before, I think in chapter 1, where we said the annual average total rainfall in the northern and southern hemisphere are almost the same. So even though ITCZ is to the north and we haven't clearly explained why that is, it turns out that the great cloud bands give us the same amount of rain when we look at the total annual rain. So maybe the ITCZ is more of an energy equator than this land distribution story. Of course, as we saw, there are differences in the land versus ocean distributions because of the differences in land area or in the two hemispheres. Looking at the synoptic wave characteristics for the Southeast Indian Ocean and the SPCZ, so base point of 30 south and 105 east, 30 south, 135 east. Phase speed is much faster in the Indian Ocean, relatively weaker here. Wavelength is slightly longer, and the wavelength is slightly shorter in the SPCZ, and periods are somewhat similar. So obviously the trade winds that are very strong in the Indian Ocean to the north and the westerlies at 30 south have a different influence on the interactions in the southwestward stretching Great Cloud Band in the Indian Ocean versus the southeastward stretching Great Cloud Band in the Pacific Ocean. Okay, that's something to keep in mind. If we look at synoptic wave characteristics for a disturbance propagating through the SPCZ at lags of -2, 0, and +2 days, with again base point at 30 south, 135 west, you see that the phase speed drops greatly as you go through the peak convection through this point. So wavelength also drops significantly. So the phase speed is slowing, wavelengths are getting shorter, so wave number is increasing because the period remains the same, or the frequency is imparted by the forcing. So you can see the change in the relative balance terms we talked about. Heating and vertical terms, temperature response versus advection and heating terms, right, is very different, and the zonal stretching is going to influence the waves as well as you go towards higher latitudes. So this is shown here in this figure, where we are looking at OLR again and 200 hectopascal zonal wind stretching information, 3 to 6 day bandpass filtered, and this is for latitude longitude regressions at lags of -2, 0, and 2 days. Okay, so just visually you can see that as with the lead lag days in the longitudinal directions going from the western Pacific to the eastern Pacific, there are clearly so you are going from days before to day after, so you are propagating in the west to east direction, and there is a correspondence again between the stretching and convection or OLR. You can see that here in the map, going with regression with the same base point, -2 days, 0 days, and 2 days. This is done in many papers also by releasing Rossby waves at different wavelengths and periods with background basic states and seeing which way they propagate and so on. So heating always generates Rossby waves, and we also have westerly wind regime here doing its own thing. So you have this great feature being set up, still not completely explained in terms of why it's anchored this way, and we are just looking at the transients within that. Okay, we'll repeat the conclusions just to conclude the chapter so that we kind of synthesize the ideas, and repeat what we said in the beginning to just highlight the main points. As I said, I have kind of skipped the details on some of the equations because even though they are useful, the details are important if you're getting into specific processes related to these ITCZ and Great Cloud Bands. If you're just trying to get to the tropical dynamics for other processes, then you can just be aware of the dynamics here and the processes, and then go to your specific interest. Okay, that's the way I think about it, but if there are issues, then just message me. Okay.